Okay. All right, this is the day 8. All right. All right, so for this stream, we have to finish the phase 1 of the interpreter. So I did do a little bit of work off stream yesterday, so I just changed oh, let's get this out. What is here? Okay, basically what I changed is, this is an array before, so I changed it to a vector, so we can resize it whenever we need. If we need, oh, I accidentally closed the main. Let's go back. And inside main, I basically just finished off the rest of this part. I just hard-coded some values just like yesterday. I think this is already here yesterday. And then just made some output, simple output, and then made modes. So if you select 1 or select 2, it goes to the mode that's there. So essentially you can just, I'll just show you guys real quick. Alright, so right here, so select mode. So if you press interpreter, it will do the files, the binary, and it will show what values in the registers that we just put. Yo, what's up, EXO? Long time no see. Just talking on stream, bro. Just talking on stream. And then we have our other mode. If we press the disassembler mode, so now we need to enter a 32-bit binary string. So let's just grab one. We can just look in Gemini. Grab. I need to generate me an example bit string for add I instruction, or let's do a different instruction. Let's do load word instruction on risc-v. Anyways, I'm making an AI for my game. It's gonna be a 3D AI on Roblox. It's gonna be very advanced, kinda. Nice, man, nice. How's that gonna work out? Like, what's the AI gonna do? Alright, so we have the load word for x10, and then the offset will be 8 for the register 5. And let's grab the string and let's put it in here. So as you can see, for this mode, it will take a bit string, 32-bit string, and convert it into the assembly instruction. So we have this one. It works. Oh shoot. As you can see, it's the same. Load word, x10, and then the offset of 8 put into the register of x5. And yeah, and then you can just do as many as you want and press quit if you want to exit out the loop. So yeah, that's basically what we have so far. So now we need to just add some more stuff here before we move on to the next phase. Alright, just get rid of that. Alright, so the next thing we need to do is actually allow the user to input instructions properly. There's going to be 2 versions, one for admin and one for players. The one for players will give players hints, tips, and more, and players will be able to chat to them, so the AI is 2D. Nice, nice. I've actually never seen that implemented into any Roblox game so far, so that will be pretty interesting to see. Alright, so let's see. So we need to change these values. Instead of being hard-coded, we need to allow the user to enter their own for now until we change to reading binary files. So, I mean, I guess just calling the function for convert binary, get binary, my bad. Get binary, just calling that function each time separately. Same here. If the admin one is going to be 3D, and with the 3D avatar, it helps admins give ideas and other things like that. There's going to be a special third version for the owner. Okay. Sounds pretty interesting. What do you mean, like, helps admins give ideas? Like, ideas for, like, the game, or what? I think this should be fine. So if we go into our insert, oh my bad, I went to the wrong word. Still getting used to this new keyboard. Alright, so 32-bit binary string. Alright, so let's just get 4 instructions. Or okay, wait, hold on. Show Gemini what we have, not Gemini, Cloud, what we have so far. And so, okay, I changed it to allow user input. We'll be able to send global messages like me and do cool stuff like AI admin only weathers and add special things in shop template. Isn't that already like a feature though in Roblox? Like you can already send global messages if you're an admin and do random stuff. Archive for instructions. You're right. That's good. That's good. Okay. Okay, so we can actually ask the user to input an amount. So let's see. So initialize those, and we can ask the user to input an amount. So let's just create a variable int. We'll just say instruction amount, and oh, the AI will have its own abilities for like admin abuse. Okay, I understand. All right, that makes sense. All right, so for the instruction amount, just 0 initialize it, and I guess enter the amount of instructions. The amount of instructions, and then some user input for that. And in my game, it's going to be Lethal Company and Among Us now. And there's gonna be consumables for boost and just for fun effects. Nice. What is like your game exactly about? Like, what is like the main objective for your game? Alright, so okay. But we do have like this, right? So guessing we need to the amount of instructions. I guess it'd be better to use a while loop instead of for loop so they can exit out whenever they want. This type the amount or this thought and whereas a for loop would give them needing to put that second amount. This is going to be mostly like Among Us, but there's an extra thing about it. There's consumables, there's also this grinder, so you pick up scraps on the ground, put it in the grinder for money. It's going to be blue ribbon backs for XP. What are like the consumables used for? Like for boost and fun effects? I think I'll take the while loop route, so we don't need this. Instead, we need to have a while true loop. I keep forgetting it's not capital in this, it's only capital in Python. And where would I want it to be? Right here. Yeah, so now it goes like that. So for now, we don't need enter the amount of instructions. Enter. It'd be the binary. Binary instructions. Done and finished. Okay, so that would work. Okay, so now we're entering binary instructions, so we would still need to have the binary string. So for the case of this, I'm gonna go up and grab this, because we would also need to reuse this, so we'll call it, so it'll just be that stitch string binary string. And then that would turn into an unsigned into value. And that would be convert binary of our binary string. Yeah, that's what consumables are mostly there for. The money you're going to be able to buy the consumables in the food shop and the map, and you're going to be able to buy jobs like the engineer. Ah, okay, I see. So there's just like more mechanics you can have. I see. Alright, so we have the unsigned value. So now our binary string is set there. And essentially, we don't need this out, so it'd just be like this. And then don't need to convert either. This is the value. Second value will be our value that we converted. So that should work. And then we'll run the values. Okay, this seems pretty good so far. I'm just gonna go ahead and ask Gemini for some instructions. Give me a list of 10 random risc-v instructions. Risc-v, they're 2-bit instructions that end with equal. Oh shoot, I didn't specify I need the bit strings. I need the bit strings. Them all as bit strings. Well, I don't want them separated like this. Okay. I want to like a whole. I don't know why. Okay, Gemini, you're being kind of dumb. There's also going to be events and event activities to get exclusive stuff, and there's going to be a fruit event. You're going to be able to blend fruit and stuff and to make consumables and more stuff. That's pretty nice. I mean, it seems like a pretty fun game, not gonna lie. If you can get that made, I think that'll be pretty nice. Alright, there we go. That took three queries to get this properly. I guess I should have been more specific, but it's okay. And what happened? Oh shoot, yeah. It was already open. I need to give me a second. I'm gonna close this. Alright. There we go. So now if we have a 32-bit string. Oh, we still need to add more logic. I shouldn't test it yet. Yeah, we don't need these. So how do we know what register? I guess we can print out all the registers at the end. We don't have to have it immediately. So in the case of this, I'm just gonna ask Gemini. No, my bad. We'll just make a for loop. Guess that this will be after the loop, the while loop, so it gets all the values out. So far for the game, you have the map lighting and the main menu done, but none of the GUI done. But I do have to think about the player model. Yeah, that's true. I mean, that's pretty good still, getting the map lighting in the main menu. I'm sure like you have a couple people working. Like I saw in the Discord, you had some people working on it. GUI shouldn't be too bad, but player model might take a bit because you have to do some 3D modeling. Yeah, you sent me the player map lighting and stuff. It looked pretty good. It looked pretty good. Alright, so and here I guess we can have int value. Oh wait, no, we already have value. My bad. Let's call it let's go back in here. So, yeah, we'll call it address. That's probably a better way to call it. And then after that, we'll address plus 1. All right. Now it should work. Let's just do a couple and do it. We still have a print, don't we? What's wrong? Wait, so I was an unknown instruction. Wait. Give me a second. Oh no, those people are just giving me ideas. I'm still one person dead. It's pretty ambitious, man. Good luck to you. As long as you just keep going at it every day, you'll get there. Okay, so let's check why it's working right there. So what went wrong when we did it here? Let's see. Binary structure. Okay, so we're getting the binary string, converting the binary string. What's going on? Writing the words to the value, right? That should be right. I actually don't know what's going wrong here. Core run. So first reading the word at the program counter. I think I'll ask Claude for a second to see what's going on. Might be missing something here. Let's just make sure I did that right. Like, so this instruction, right? Thing on instruction, yeah, so something's clearly wrong with the logic. Right, silly mistake, bro. Just reset it every time. On the outside. I forgot. Well, that was a silly mistake. What else? Each instruction's 4 bytes to addresses. Oh yeah. Yeah. It's not incrementing by 1, it's incrementing by 4. Right. Forgot. There's more leaks on DMs. You can see the GUI for the AI in the AI model so far. Alright. I'll check it out. Okay, what else? What other bugs did we write? Core runs inside the loop and emulator after every single instruction type. Right. So, wait. Memory, so reading the word, decoding the instruction. Running the emulator after every single instruction typed. Okay. Yeah, I guess. And okay, so right word. But why wouldn't we keep it in the loop? Exactly, right? So let's also write our logic for this. So if our binary string is equal to done, break out the loop. Okay, let me just test this real quick. Okay, so we're going to interpreter. Let me grab the bit strings. Let me just test it. So let's just do. Alright, let me just write quit here. Okay. Alright, so that instruction was to load in the value of 10 added to the value of the register x6 and storing that in the value into the register x5, which seems to have worked. Yeah. I mean, that works. But it's still saying unknown instruction at PC8. It's not. Oh shit, bro, why did I click that? So we got this so far, and then our output was. Let's see, there has to be some little mistake. So it's not understanding what instruction is when we call or we run, right? But why not though? Why is it not understanding that? It's a main core problem that we need to understand. User types done, reminder runs on it before you check for done. Tries to. Did we really write it before? Wait, hold up. Oh, my bad. No terminating instruction. After you add one added instruction, there's nothing to halt the emulator. It executes add items advance the program counter for and then fetches from address, which is 0. Oh, yeah. Okay, I see. That's why it's saying unknown instruction add program counter 8. Okay. Okay. We need to always end with an e break. What is it? Okay, no. Can you give me a 32-bit string for e break? So we have that. So we always need to have at the end of that instruction, we need to have e break at the end. So that would mean it needs to be outside of the loop, but how do we end up doing that? So I guess, okay, since the address is being saved in the values, we can still access it, right? So we just need to get the address value that is being done. So we need to create a new variable, or we don't, it's probably better to create a variable. We can call it int, no, I can't do that. I'll just call it int ebreak. Right, and int ebreak will be our address value divided by 4, so we can get the amount of instructions that are there. And we need to we need to advance forward by 1, and for that instruction we'd be writing e break. Here, we can hard code the value in for e break. I think that's important to do. Alright, so writing word has to be unsigned value, my bad. I think I'll just get this in hex first. No, binary to hex. Get the value in hex. It's this number in hex. Okay, that should work. Sorry, go back in. Alright, so now we're going to the interpreter. Let's try that one bit string. Done. We're still not getting it. Still not getting it. Still not getting it. Just the floor. Let's see. Okay, so I was thinking about it wrong. That's my bad. Right before we exit out the loop. Well, wouldn't we still need it? Okay, wait, yeah, I understand. Right before we exit out the loop, it's gonna increment by 4 and then go back here. We'd enter done, so we'd already have incremented by 4. So we just need to. We don't need to do anything. We just need to. We don't need this variable. We just need to access it at address. At our address value. Not address. Just access our address value and then immediately print out. So let's see. We have our nice. Nice, guys, nice. Alright, that actually works. Okay, yeah. Probably. So with that, we should be done with phase 1, I'm pretty sure. Is there anything else we need to do? Alright, so we got our different modes for the disassembler and interpreter. And we have all the logic done for this properly set. So I think we're pretty much done with that. I can't really think of anything else that we need to do. So I think we're done with that one. Yeah. Okay. So now we actually have to understand how to get the binary files. So it can read from binary files instead of taking from user input itself. That's our next plan of action. Yeah, I'm just gonna commit this real quick. I'll be right back. Alright, so to implement binary files. Okay, I'm gonna commit this first. Hold up. Vl commits and push that code. Okay, let me check GitHub real quick and I'll be back in a second, guys. Let me check it. Let me check if it commit properly. Yeah, it seems to be good. We committed it properly. Alright, yeah, that's perfect. Let's get back on. Alright. Alright, next plans of action that we need. So we need to actually get it to read from binary files instead of taking user input itself. So I'm gonna need to do some research on what these binary files actually look like. We can implement two like dot and files. Okay. I guess we can do some research on what they are. I know like they're for binary, but how they look and how it'd be. Okay. Interesting. Different text files which are human readable and can be edited with a text editor. Binary data is not. Yeah, okay, I understand that. Bin file storing, save game data. Okay. I mean, it seems pretty straightforward. It seems pretty straightforward. Okay, we're gonna have to take a look at what this is. Did if stream. Implements high-level input operations on file-based streams. It interfaces a file-based stream buffer with high-level interface. Okay. Implementation of basic stream on non-derived data member. Okay. And what exactly do we need to look for? iOS binary. Okay, so file name, put in the string, okay, file to read instead of stream, file name, and then we use the command instead of binary dot write, reinterpret cast. I forgot what reinterpret cast was. What is that cast again? Totally forgot. I know I read about it a couple weeks ago. Interpret cast type of casting operator using C++. Yeah, okay. It's used to convert a pointer of some data type into a pointer of another data type, even if the data types before and after conversion are different. It does not check if the pointer type and data pointed by the pointer is the same or not. Okay. So we have our data type, the pointer to the variable, reinterpret cast, the data type, the pointer data type that we want, and then our pointer variable. So it's okay, so it's essentially just converting the type of the pointer. Is that it's used? So how is it? Okay, so how is it? How do I? Oh, okay, wait. So we have a reinterpret cast a char pointer. Okay. Size of the 3. Okay. Because that's basically just preparing the file to read. Now we're opening the file here, so now that's where we used if stream. File name. So I was okay. So if so if this stream is not open, failed to open, and then else we basically set whatever we need. Okay. Okay, so why do we need this variable here like that? I kind of get it, but also don't. So I'm going to clarify a bit more with Claude and see. Okay. Okay, so let's run through. That's just okay. Oh wait. Oh, this part's creating a file. Okay. Oh, that's why. Okay, that makes sense. I was wondering what this part up here was for, why we were having a variable here, doing a reinterpret. Okay, that makes sense. So we're making the file here, and then here okay. Let's read. So sequence file for reading binary mode. Static stream means the input file stream. Yeah. Flag tells it to not do any text translation. Okay, so it's just reading the raw bytes. Just the binary from it. Doesn't exist or the path is wrong. Returns false. String.read. Cast. Okay, this is actually 3 things happening here. It's actually how many bytes to read. The reference to D is where to store them. And reinterpret cast char pointer. So read expects a char pointer, so you cast your destination to that type. Okay. You don't need to read into a double, you want to read bytes directly into your memory vector. Byte by byte. Okay, let's give it a try. Let's give it a try for our program. Let's give it a try on reading a file. I guess I'll just write it here for now. I might have to move it, but just for now. So just want to get the practice of it. So guess it just start the same, right? Right, it just start the same as this part, so. File name and allowing it to read directly into the binary file without changing it. Size binary. And I guess we can make a name. Yeah, we'll just call it test.binary as well. So, okay, so binary. Oh, we need some include headers. Top. Let's leave there. Okay, right, so that is like that, right? So essentially we're telling the file that we can read directly from the binary file without changing it to text. Okay, now we have to validate it, so. And dot is open. And for this case, we need to just say that. Else. Now here's where we have to do so. From the read, enter, cast, char, pointer. The reference of what though? What are we actually doing? So, okay. How many bytes to read? So would we do a vector dot size? Is there an operation to do that? Vector dot size, like or C++? Would it just store that? I mean, we'd be storing them into our memory struct, right? So would be storing it in the vector, right? It's not gonna be char, so. Okay, I'm kind of stumped here. I don't really know. But then the other parameter, I guess, is there like a way to do vector dot size? I guess we can ask. vector dot size is actually vector dot size, so that's fine. So vector dot size actually exists. Data. Okay, so it always expects a chart pointer no matter what. What is the dot data function? Dot data vector. Turns a pointer to the first element of the vector as an internal array. If the vector is empty, the return pointer is not dereferenceable. Changes in an internal array reflected in the vector. Traverse whole vector using data. So vector pointer array, vector data, vector size, and the pointer. We're dereferencing. Okay. Okay, that makes sense to why we needed that. So okay. Besides the actual the file size, not the memory size, you only want to read as many bytes as the file contains, not the entire yeah. Okay, so not the entire vector. So we're gonna need the size of it. So seeking to the end. I don't know what this is, to be honest, but okay, so risc-v. Moves the read position within the file stream takes to organize the offset, how many bytes to move, direction, where to move from. So from the beginning of the file, from the end of the file. Okay. From the current position. I see. So it tells you returns the current position of current position. Okay, file size. Move 0 bytes from beginning equals go back to start. So we're just setting it back to the start. After that. And I'm guessing this is why do we need to set it back to the start? Is that for like any future binary file or something? code read right there. Try to read from the end, finding nothing. You need to rewind to the beginning. So read starts from the first byte of. Okay. Jump to the end, jump back to the start, and then read it. Okay. So I think I got generic idea, so we're visiting the end. We're setting the file size, so it's gonna be size t. File size equals that reads the file size. And then it would just be the file size. That'd be the file size variable that we had here. And yo, what's up, Zai? How you doing? Welcome to the stream. Shoot, my bad. I gotta put a semicolon here. Okay, it took a while, but I think I kind of understand how to read files now. We can set up a separate function for that now. So I just copy what we have from here. Okay. So we need to distinguish a couple things first. So creating our memory struct. Instantiating it. I think that should suffice for that. I'm kind of worried that will this potentially collide with the potentially it might. Let's see. Just have the function create the memory object that gets destroyed when the function returns. To load into an existing memory, that core can then use the memory should be Okay. string to the file name. Make it a string reference to the file name. And how can we load the memory structs? So I'm gonna call it since this has to do with reading memory, right? So I guess it would be in here. So yeah, we can. So I'll add a different choice. So interpreter, call it user input mode. Choose option 3. Get us the interpreter for the .binary file. So what mode should be called? Loading file. Okay. Mode. There, I can make it lowercase, so it's more distinguishable from the other parts. Okay, so it should be fine now. choice is 3. Essentially, we're creating the memory struct and calling in the load program function. Taking in the user input. Wait, before that, we need to understand what the user input is. Right, so let's see out. Test that one. So yeah, like something like that. I assume so. Name it that bin file. Then we want a string. Call it. And we will call and we will make it should be our file name. And then we are loading the file name, right? Because we had the file name reference. That's the parameter, so it should be the file name, and then core. Not mem.core, my bad. Core dot. It should be execute as a name. No, core dot run. I need to create a core. Hold up. Change it at the top here. Core dot run. What are the parameters for that? It's the memory address. So, okay. Looks to be good. Looks to be good on that part. Let's give it a clock. Wait, what? Program. Let's try an option 2. I forgot it. Oh, wait, where? Did we not just add it? Oh, he means this. Yeah, you're right. What else did we miss? Load programs define main LCP. Every load program definition should live in the interpreter LCP. Okay. I just assumed that since this IO handling that it would be in here, but I guess not. We can move it though. Just move up here. And right. What else? Const on file name parameter still missing const on the load program parameter. Both declaration should be const. Why should it be const? Maybe only being it's open file. What is that? Yeah, okay. I guess, yeah, it's not changing, so we don't really need the... We can make it a const. So const is the string reference file name. Change that interpreter. Hey, what's up, Arihara? How you doing? Welcome to the stream. Change it in our interpreter as well. Make it const. Not const. Const. I think everything's set right. Alright, so looks like that's done now, so should be done. Looks like the logic for this work is done now. I made all the changes that you mentioned. We can do that. Right. Later load it into memory right after the instructions. That's fine. eBreak calls execution for the PC. So we don't even need this part. What about the global part and stuff? let's check this again. This is my first time creating a binary file, so I'm actually having some difficulty on seeing what to do. I really don't see one, not gonna lie. Damn, that's a lot of steps, bro, just to get a binary file. Alright, I'll be right back. One second, guys, 1 second. Yeah, so I think for now it's fine. I don't think we need to test out that part for now. Yeah, it seems like it was a successful stream today. We got quite a lot done. And I guess, yeah, we can continue off tomorrow with the next parts. So yeah, see you guys tomorrow.